You can see that hydrogen has 1 electron in its outer shell. Here is lithium. It has 2 in its inner shell, because it can only have 2 in its inner shell. And then only 1 electron in its outer or valence shell. Here we have sodium. 2 in its inner shell, a full second shell of 8, and then only the 1 in its outer shell. All right. Once again, valence electrons are used for bonding. Used for bonding. 4 or less electrons in its outer shell, such as in groups or families 1, 2, 3, and 4. They're going to bond really easily by giving away those electrons. When you have 4 or more, when you get to the full ones, when they're closer to full, they want to bond, but they're not willing to really give away anything, so they're going to wait for you to give them something. So sometimes it takes them longer to bond. Here we have a carbon atom that is bonded with 4 hydrogen atoms. Now, carbon has 6 total electrons, 2 in its inner shell and 4 in its valence or outer shell. You can see the carbon electrons here in blue. 1, 2, 3, 4. Once again, these elements want to have full outer shells. These atoms of elements want to have full valence shells. And a full shell is 8. So it's sharing these electrons with hydrogen. So here hydrogen is sharing its red with carbon, and it's sharing carbon's blue with itself, with hydrogen. So hydrogen has 2 electrons in its shell. Hydrogen only has 1 shell. It can only have a total of 2. So hydrogen is full. Carbon has these 8, so it is full. Some of these atoms have low amounts of electrons in their outer energy level, their valence shell, so they bond easily. Beryllium only has 2. Sodium only has 1. They bond very easily. These atoms have almost full shells. They don't bond as easily. Do not bond as easily. Here we have some oxygen. It's got 6, almost full, so it's going to wait for you. It's going to wait for you to give it something. Helium is full. It's not going to bond very often at all, right? And here we have fluorine. Fluorine is very, very close to full. It has 7 electrons in its outer shell. And some of these, they're almost full. They're close. They're in the middle. They're going to bond easily. They're not going to bond easily. Sometimes it's based on the situation that the atom is in. And so sometimes you just have to watch and see what happens. All right, moving on to another important feature of the periodic table, the periods. Right, these run horizontally, side to side. The periods run horizontally. The horizontal rows of the periodic table are called periods, and you can see there are 1, 2, 3, 4, 5, 6, 7 of those horizontal rows. There we go. You can highlight and see those horizontal rows. See those periods. We call them periods. All right. So let's talk about the periods. Why are they special? Why are they special? Well, there's 7 of them, like we just said. As you move from left to right, the atomic numbers and atomic masses increase once again. So from top to bottom on the periodic table, atomic masses and atomic numbers increase, and from left to right. So as you move down and as you move from left to right, elements have more protons and they are heavier. The great thing about each period is that elements in that period have the same number of orbitals. They have the same number of total electron shells. That's why we arrange them like that. That's why we arrange them like that. That's why the periodic table is set up the way it is. Right? Because each period, same number of orbitals. So if you're in period 1, you have 1 orbital. If you're in period 2, 2 orbitals. Period 3, 3 orbitals. I think you get the picture. So here we go. You've got these two atoms of an element. It has 1, 2 orbitals. This one has 1, 2 orbitals. So what period would these two go on? That's right, period 2. Let's count these. That's right. Each of these has 3 levels, which means they go on period 3. Absolutely. All right. Moving on. We're done. That's right, folks. So hopefully you learned a lot about the periodic table. Remember, important information. The groups or families, those are the columns. There are 18 of them. Elements in the same group or family have very similar chemical and physical properties. They have the same number of valence electrons. That's their outer shell. That is the shell that is used for bonding. That's the very important shell. We will talk about these a lot. Also, remember, the horizontal rows, the periods, they tell you how many total electron shells an element has. And that is why the periodic table is arranged the way it is. It shows us lots of information about elements. And all you have to do is look.